Hello friends, in the last video we have seen how to apply Newton's second law when there is no friction present. Now in this video we will see how to apply Newton's second law when the friction forces are also present. So the objective of this session is to analyze the straight line motion with friction. And this we will illustrate using a problem. This problem we have already done without the friction force. Only the difference in this problem and the previous problem that we have done in the past video, there is a friction force in this case. So the problem says, suppose a constant horizontal force with magnitude of 100 Newton opposes the motion of the iceboat. This is a constant horizontal friction force. This opposes the motion of the iceboat as shown in the figure. So this is the iceboat and he is the rider, and this iceboat is moving in this direction, and there is a friction force between this surface and this iceboat that tries to oppose the motion of this iceboat. So this is acting in this direction and the magnitude of this is 100 Newton. Let's call this as a small f that is given in the problem. In this case, what constant force Fw must the wind exert on the iceboat to cause a constant x acceleration, that is x is equals to 1.5 meter per second square. So what is happening in this case? Basically wind tries to apply a force. Let's call this force as Fw, that is force due to the wind. And this force will accelerate the motion of the ice boat. And finally, basically at t is equals to 0, this ice boat just starts its motion, that is initial velocity is 0, and after a certain point of time it gains an acceleration, and the value of acceleration is given, that is 1.5 meter per second square. So we have to find what is the magnitude of wind force. And this is constant magnitude. So this is a constant wind force. The combined mass of ice boat and rider is given, and this is 200 kg. So how will you solve this problem? So let us first write what are the things that is given. So what are the things that is given? We have been given friction force magnitude, that is 100 Newton. Mass of ice boat plus rider, that is given, that is 200 kg. And we have been given the final acceleration in the x direction, that is 1.5 meter per second square. And we have to find the Fw, that is force due to wind. So how will you solve this problem? Hint comes because you have to find force. And what are the things that is given? You have been given acceleration, mass. This all gives an idea that is we are going to apply Newton's second law. So that is we have to apply Newton's second law. And then we have to write equation and then we have to solve. But before that, for applying the Newton's second law, I have to draw the free body diagram. So in this case, this will be the flow chart for doing this problem. I have to first draw the free body diagram. And once I have the free body diagram, I have to use Newton's second law, that is writing equations. So Newton's second law. So once I have equations, now I can solve this equation and I can basically get the unknowns. So then you have to solve the equations. So let us first draw the free body diagram. So this is my ice boat and rider. So what are the forces that is acting? One force that is obvious is weight that is acting in the downward direction, that is nothing but mg. So let us denote this ice boat plus rider as a point mass, and the forces are acting in the downward direction is mg. Normal reaction will come from here and come from here, but we will consider all the equivalent normal reaction that is passing through this point, and the magnitude of this normal reaction, let's call this as n. So this is normal reaction. So this is my y-axis. So this is my y-axis. Similarly, now we can assume this is our x direction. So this is x axis. What are the forces that is acting along the x direction? One force that is acting this due to the wind, that is Fw. So we can show this force Fw something like this. Friction forces are also acting, but friction forces act in the opposite direction of the motion. Friction force always tries to oppose the motion. So this is moving in this direction, so friction force will act in this direction. So in this case, the friction forces are acting in this direction, and this will act at the point of contact between the iceboat and the horizontal plane. So this force will act in this direction, and the magnitude is F. Now once I have the free body diagram, I can write equation of motion. So let us first write motion equation in the x direction, that is summation of all the forces in the x direction is nothing but mass times acceleration along the x direction. So what are the forces that is acting in the x direction? One force is Fw, that is positive side of the x direction, and friction force that is in the negative direction, so this is minus F, is equals to mass times acceleration. So if you plug all this value, we can calculate magnitude of force due to the wind. So we can write Fw is equals to F plus max. Friction force is given, that is 100 Newton, mass is given, that is 200 kg, and acceleration is nothing but 1.5 meter per second square. So if I plug all this will come 400 Newton. So the magnitude of force that is applied by the wind is equals to 400 Newton in this case. You can also find normal reaction if you consider equation in the bidirection. That is, in the bidirection there is no movement, there is no acceleration. So we can say summation of all the forces along the bidirection is equals to 0. This means in the bidirection is normal that is acting, and the mg is acting in the downward direction, that is minus mg is equals to 0. So this gives you n is equals to mg. Now if you compare, we have done the same problem, but there was no friction. In that case we found the Fw value was 300 Newton. You can see in the previous videos. So in that case, when F was 0, that is there is no friction, in that case Fw was 300, and when there is a friction of magnitude 100 Newton, we found that Fw is equals to 400 Newton. This makes sense. If the friction is present, wind has to apply more force, because some of the force of the wind, that is the force applied by the wind, is resisted by the friction. And how much this resistance is? This much resistance is 100 Newton, and that's why the difference between these two forces is 100 Newton. So you see, if you have a friction, you have to apply more force, the wind has to apply more force. I hope you enjoyed this video, and if you enjoy, please share, like and subscribe this channel, and hope I will see you in the next video. Thank you.